Okay, welcome everyone to CS 4150. I'm Joe Zachary, if you don't know me. What we'll do today is get started just talking about what you should expect during the course of the semester with the syllabus, and then we'll start talking about some course content. Let's see if I can turn that. That's no good. Is that screen visible, that light on there?
That's fine.
Okay. You know, they did this remodeling last semester, and I had one big complaint about the room, and it was that light right over the screen. And they left it inexplicably. Okay, so let's talk first about the prerequisites for the course. You need to understand basic algorithms and data structures, as in 2420. So you should be solid with algorithms for sorting and searching, lists, trees, hash tables, big O notation. Okay? We'll do some reviewing at the beginning of the course, first week and a half or so. But it's just a review, and so you need to come in with a working knowledge of those topics, or you're going to be behind from the start. Okay? So if 2420 is something that you took and went, glad that's over, and haven't thought about it since, it might be a good idea to start thinking about it. You need to have some programming competence. I think that's easier to come by. You essentially need to be able to take a high-level description of an algorithm and convert it to code, because you'll be doing a weekly programming assignment. Now, the good news is you get to pick the language, so you can program in whatever, well, within limits. The system accepts something like a dozen languages, so it's probably, your favorite is probably one it accepts. You need to have a little bit of facility with discrete math, as in 2100. So we're talking about exponents, logarithms, summations, products, simple proofs, simple probability, discrete probability, sets, functions, relations, graphs, trees. That's sort of the language of algorithms. So in order to make descriptions precise, we need to talk about sets or trees or logarithms or summations over a sequence, that sort of thing. So essentially, 2420, any number of courses for programming competence, and 2100 are the prerequisites. Okay? Now, I don't like to talk and have none of you talk, so please feel free to interrupt me and ask questions if you have any. So do you have any questions yet about like the background you need? Yeah.
The probability kind of sounds weird to me. Is there like complexities that have like a probability of being one complexity over another? Okay,
so he's asking, what's the probability for? Is it because when we do complexity analysis, there might be a probabilistic complexity? No, the answer is some algorithms are probabilistic. We'll be studying algorithms that probably work. Or that probably work efficiently, but not all the time. They work all the time, but they're only probably efficient. Okay? And I just want to point out, you know, it sounds funny to think about an algorithm that probably works, but public key encryption, the key generation step for public key encryption, probably works. So when you order something online and encrypt your credit card number, it's probably secure. So we'll be making sense of that later. Is there another hand up? Okay. All right, so there'll be weekly problem sets due on Thursdays, except the week of the midterm. And the problem sets will be in two parts. So there'll be written problems, and they'll be on Canvas. And they take the form of what Canvas calls quizzes and what I call essays. So a quiz is something that you use in Canvas, and it's either like multiple choice or it's short answer, something that can be graded very easily. That's just functionally, Java calls it a quiz. I mean, Canvas calls it a quiz. So you just do the quiz and submit it, and eventually it gets graded. Canvas essays just means instead of having a place where you write a word, you might have a place where you write a paragraph. So I used to have people hand in paper years ago, and then I had people hand in PDFs online. And now I do it on Canvas. It's sort of the same assignments, it's just different medium. So those are the written problems. In typical problem set, you'll have 4 or 5 written problems. And some of them will be quite straightforward. So for example, if we're studying an algorithm for depth first search on graphs, a quiz might be, here's a graph, give the order in which the vertices would be visited during the algorithm. So it's just a matter of, can you run the algorithm in your head? Do you understand the algorithm? And others might be to do an algorithm analysis or do a complexity analysis, something like that, describe an algorithm. So when I say a problem, I mean it's going to be a Canvas quiz or a Canvas problem with multiple things to do. And those are due on Thursday. And then there'll also be a programming problem due on Friday. And typically a programming problem will be related to some algorithm we've studied that week. So it's due the following week. And it'll take the form of a written, there'll be some often fanciful scenario described, and you've got to write a program to solve the problem. And you'll be doing that on Caddis, and we'll talk about that when the time comes. Yeah.
As for writing out the program on a separate, I'm assuming it's nothing like Canvas, it's its own thing to turn into assignments. Are we allowed to write our programs like on Visual Studio, copy them, and then place them onto?
Yeah, you'll see that all Caddis is, your interface to Caddis is, there's a place where you can either drag and drop a file, or you can copy and paste your program. So it's not an IDE. So you write the program however you want to do it, Visual Studio or Eclipse or Python, whatever. I usually copy and paste it into the web page. You hit submit, and it tests it, and it tells you if it was right or not. So the challenge you'll have with these Caddis problems is, when you submit the program, what you get back is, it either passed all the test cases, it failed some test case, it ran out of memory, it ran out of time, or it had a runtime error, an unhandled exception or something like that. It doesn't show you the test cases. Yeah.
Would you recommend optimizing your algorithm after it passes all tests, just to improve your knowledge of what's happening?
Okay, so he's asking about, he's wondering, do I recommend optimizing the algorithm after it passes the test? Not necessarily, no. I mean, for most of the Caddis problems you'll be doing, there's a generous time limit. And there's a leaderboard that shows the top 10 solutions, the time for the top 10 solutions. For the point of time we've been using the Caddis in 4150. And at the top of the board, when it goes across all languages, what language do you think has the fastest solution?
C++.
Well, C or C++. It's mostly C++ because not many people use straight C. So C and C++ are at the top, and sometimes they take, rounded to the nearest hundredth of a second, it takes 0 seconds. Okay? And then next you see C# and Python, and down here at the bottom is Java. Okay? Now, if your program is just barely is taking too much time, maybe you should use a different language. But that's not usually the case. Usually the problem is algorithmic, it's just taking way too much time. And I'll just tell you in advance, the problem with Java isn't that it's intrinsically slow. It's slower than C++. It's that the scanner class is really slow. And some of these programs take a tremendous amount of input. Fortunately, Caddis provides a sort of a substitute class for scanners called cat.io that is a lot faster than Scanner, which is worth using if you're using Java. But anyway, that's a topic for another day. Yeah?
Will be allowed multiple submissions on the code assignment?
Oh yeah, right. Okay, I cut you off. Multiple submissions on?
For the programming assignment?
Yes, you can submit as many times as you need until you get past the test. And yeah.
So does it matter for the top 10 leaderboard? Is that just for us to see?
Yeah, it doesn't matter if you're on the top 10. The sad thing about the top 10 is that it's already occupied by students from previous semesters, and it's hard to dislodge them because if there's a tie, it goes to previous submissions, and sometimes the top 10 is all like 0.0 or 0.1 or something. Yeah.
So I'm assuming there's not like separate leaderboards for different classes or languages?
There are separate leaderboards for languages, yeah.
Okay.
Yeah.
Do we also have multiple submissions for the quizzes? Or is
There's,
that-
yeah, for multiple submissions for the Canvas things, yes, but you don't see the grade. It's not like you submit and see your grade and resubmit. But you can submit and change your mind and resubmit. Yeah.
Do we get a grade drop for every extra submission we get, or is it just one?
There's no penalty for extra submissions.
Okay.
Okay, people sometimes ask about my late policy, and here it is. You can use up to 15 late days over the course of the semester, where a late day is one problem. I don't mean one problem set, I mean one problem handed in one day late. So a problem might consist of, a dozen subparts. So the problem is that whole thing, but the problem set consists of, 5 things like that. So if you if the first problem set has 5 problems on it and you submit them each 2 days late, you've used 10 late days. So don't do that on the first problem set. You can hand in written problems 2 days late. The caddis problems at most 1 day late because you get an extra day already for it. All right, so you can manage your own late days, yeah. Mm-hmm.
And so these late days are assuming that we still get full credit?
Yeah, you still get full credit. And before you ask, you don't get extra credit for not using your late days. So there's no advantage of hoarding them, except, you might want them later in the semester more than you want them early. Okay, now there will be a midterm and a final. The midterm is on February 28th, which is a Thursday. It'll be here in class. Our assigned final date is May 1st. And it'll be here, but it runs from 10:30 to 12:30. Your grade is half based on the problem sets and half based on the exams. And important bit of fine print here is you can't pass the class by doing great on the problem sets and failing all the exams, or vice versa. So you need to get at least a 60 on both the exams and the problem sets. Yes?
Do you mean like a 60 average between the midterm and the final?
Well, yeah, when I say weighted exam average, what I mean is it's actually, final's worth more than the midterm. So your exam average will be 60% final, 40% midterm.
Okay.
That's your exam average. Okay? Okay, we'll make use of Piazza. I assume most of you must have used, how many of you have used Piazza by now here? So, okay, most of you know Piazza. It's just a better version. We used to use the discussion forums on Canvas. Now I'm using Piazza. It's a separate system. But I use it as the discussion forum so you can, post questions to it. It's designed like a wiki. So for every question you ask, there's a place where students can give an answer, and there's a place where course staff can give an answer. And if we particularly, if we see a student answer we like, we can endorse it and just leave it. And I do that. I like to do that so I don't have to type my own answer in. Okay? So I encourage people to participate and answer questions. If someone answers a question wrong and you know it, you can go and, it's a wiki, you can go edit the official, the official student answer to make it right. Just be sure you're not wrong too. And there are ways to post follow-ups. So it's there for discussion. I will use it for announcements to the class. You use it to contact us. So when you post to Piazza, you can designate. Just goes to instructors, me and the TAs, and you can send to one of us via Piazza. So that's just your general purpose way. Our general purpose way of communicating with each other would be all through Piazza. Now you should get in there immediately and sign up. There's more details in the syllabus and on the in Canvas. But sign up and pay attention to how you set your notification defaults. So you can set it so that you get an email every time a post is made. I wouldn't recommend that. You'll get spammed. You can turn off all email notifications. You can get alerts on your phone, whatever you want to do. But the reason I say you need to be careful is when I want to send mail out to the whole class, I'll make a Piazza announcement, and I can tick a couple boxes and cause it to send mail to, regardless of your settings, I can force it to send email to the account you're registered with. But if you're already being spammed by Piazza because you didn't adjust your email settings, you're not going to notice my important email. So if you feel like you're getting too much mail from Piazza, you really need to not do that. So you want to ignore the mail that I send. Okay, now, there's obviously, this is talked about much more in depth in the syllabus about cooperation versus cheating. There's a section on it, you need to read it. But the bottom line is, I do not frown on cooperation. I encourage cooperation. I like it when students work together, help each other. But there are limits to what's cooperation and what's cheating. So by cooperation, what I mean is a small group of students who are about the same ability in the class, that sort of talk over the questions and figure out how to attack them, but stop short of solving them all, writing down a solution. So the group's goal shouldn't be to write down a group solution that then is emailed out to everyone and they submit it. It should just be to a support group. Sometimes these problems take a while to crack, and once you figure out how to attack it, then it's not that hard to do. So get together and brainstorm. But the answer that you submit, you need to write yourself. It can't be just a group answer, because if you can't write down the answer, you don't understand it. So the crucial definition I give in there is if you are working from any other written solution, you're cheating. So if you got your solution on the web, and you look at it and you write it in different words, you're cheating. If your group wrote down a solution and you submit it, or you look at it and you modify it and type it in, you're cheating. If you're working from a written solution, you're cheating. Okay? Now, I have the same statement in every class I teach. I had it in 1410 last semester, and I ended up on December 26th having to mail out letters to 31 students telling them they were failing the class and being sanctioned for cheating because they violated my cheating policy. So it wasn't a fun Christmas for me, and it wasn't a fun Christmas for them. So I don't want to scare you away from talking to each other, but I want you to know I take it seriously, that I don't want to see plagiarism, basically. The caddis problems are really easy to cheat on. You have to be the world's worst user of Google not to be able to find solutions to the caddis problems. Okay? So don't do that. Yeah?
You mentioned 31 students. Was that all in one course? Or was that
Yeah, it's 1410.
just one 1410? Sorry. Wow.
That was more than 10% of the students that finished the class.
Yeah.
Yeah.
So this class will have no official partner group work then at all? Like in previous classes, like this one will happen?
Yeah, there's no partner work in this. Yeah.
What level of cooperation do we have on like the Canvas quizzes where they're short answer? Can we talk about the answers on those ones?
Well, I don't want you to sit in groups and decide on the answer to every question. I mean, let's say the question, go back to my original example. Let's suppose it's, you've got to understand how depth-first search works to do the quiz. So in your group, talk about how depth-first search works. Take a different example, different graph. Talk about how it works, and then do your own work on the graph that I give you. Yeah?
So a good summary is we can discuss in groups conceptual work.
Sure. Yeah, you discuss
Then
concepts.
application is separate.
Right. Yeah?
I also want to bring up, we're going to be doing a lot of algorithm turns, I'm assuming, right?
A lot of algorithm what?
A lot of our homework turns are going to be based off of algorithms, predetermined algorithms. That
Sure, yeah. A lot of homework involves algorithms.
Yes, and so I can only assume that most of our answers are going to be similar in case of turning in algorithms. If like, for example, if we were to like do Krebs algorithm or something and turn that in as a homework assignment, most of our homework assignments will be near identical, or at least I would assume so.
Well, it sounds like what you're worried about is how do I tell the difference between coincidence and
Yes.
and cheating.
Yes.
We'll just say that I can. Yeah, I have yet to accuse an innocent person of cheating. The students, students in 1410, when I said you did this, you're cheating, you're failing the class, they say, oh no, I didn't, I'm completely innocent. And I would say, oh, here, look at this evidence. And they go, oh yeah, I guess I did cheat. So.
Okay.
You don't need to worry about that. Yeah?
How much information does the book give you to solve the problems, and how much of that information can you use?
Okay, it says how much information does a book give you to solve the problems and how much you can use. So there is a textbook. The book is fairly high level. It's not going to tell you directly how to solve any of the problems. I mean, it's going to give you the background you need. But you've got to understand what it says and apply it. Yeah?
Writing the textbook, do we need it? I've had a lot of CS classes where they list a textbook and it proves to be almost rarely used, even if they say in the syllabus it is needed.
Uh-huh.
So I want to make sure before I buy it.
Okay, here's the deal with the textbook. It's an old book. It's paperback. It's really thin. There's another standard book in the field that's like 1,000 pages and weighs about 5 pounds. This one is the opposite philosophy for textbooks. It's fairly inexpensive as far as textbooks go, you know. And the other thing is you can find the PDF online. Okay? The only disadvantage of the PDF that's online, it's something the author put up years ago, what the authors put up years ago, is that it's a PDF of the version right before the final version. And the only problem I've found is that the page numbers and sometimes the numbers of the figures, the numbers of the problems at ends of chapters are slightly off. So I just don't use those numbers when I give a reading assignment. I just say read this section or that section. So yeah, if you don't want to buy the book, find the PDF. It's not hard to find. Yeah.
So is there much of a hindrance from the number difference between the PDF and the textbook?
Is there much what?
Like a hindrance between the number difference?
No. Once I figured out there was this numbering problem, I just stopped. You know, if I want to assign a problem from the book, I don't assign it by number anymore. I describe it a different way. So, yeah.
So the textbook is more of like an auxiliary than like a main.
Yeah, but yeah, it's supporting material. Some of you can do fine just listening to me yak, but you'll find we very closely follow the book, and I think the reading will help. It's not really dense. I like the book a lot. So it's just a different point of view on things I'm talking about. Yeah.
How proof heavy is this class going to be, and how rigorous do those proofs have to be?
Okay, so he's asking how proof heavy is the class and how rigorous do the proofs have to be. It's not really very proof heavy. When we get into formal aspects, we'll do more of deriving complexity bounds than we will, say, of proving the correctness of programs. Yeah?
Do you recommend the other textbook? I think it's like called CSLR.
CLRS, yeah, Corman, Lysis, and Revest, and Stein. Do I recommend it? Well, I have a copy next to my desk of this book. It's called Introduction to Algorithms, and I use it as a reference. So I think of it as like an encyclopedia of algorithms. Yeah, I tried using it as a textbook one semester, and it just didn't work. It's just too. It's like using an encyclopedia as a textbook. So it's a great reference. Yeah.
Would you be able to post the information about that book on Piazza or something if we wanted to get it?
Sure. If you'll ask the question, I'll definitely answer it. Okay. I may not remember otherwise, yeah.
Are there TAs for this course?
Yes, there are TAs for this course. Bobby King is a TA for the course. He's right here. I think he's the only one here right now. Yeah, there'll be 4 TAs. And we will post our consulting schedule on Canvas once we've got it figured out. The first assignment will come out the end of this week, and then we'll start having office hours next week. Yeah?
You mentioned that you use Piazza to do most of your announcements. As for homework announcements, will you be posting on both Piazza and Canvas or only Piazza?
Well, I don't announce that homework has been posted. I just post it on Canvas. And you'll be expecting it, and it'll show up on your calendar if you look at your Canvas calendar. So. Okay. All right, so we will, as I say, we'll attempt to videotape all lectures and upload them to YouTube. So that's what that camera is for. And what you'll see is the video consists of some mixture of the camera looking at me and the screenshot of what's on my laptop. And they're not being live streamed this semester. We're just going to record them and upload them later. But hopefully it'll all work out and they'll be up there for reference. You know, some of you, we're going to fail from time to time, and I'm sorry about that, but it's hard to produce a TV show from a classroom like this. So I really think your best bet is to come to class and participate actively. That's the best way to learn, is to just come here and think about what we're doing for 90 minutes, 80 minutes. It's just far better than just watching a video later. Then you can use the YouTubes for review, or if you don't remember something or didn't understand something I said or whatever. All right, and this final bit of the syllabus here is what we're going to be covering. So we're going to start at the beginning here by doing a review of algorithm analysis, big O, if you will. And as we do that, we'll also review some basic sorting algorithms and searching algorithms. So we'll just sort of warm up with stuff that you saw in 2014. Then we'll talk about a class of algorithms known as divide and conquer algorithms. And you've already seen divide and conquer algorithms. Who could name merge sort and quick sort, right? Those are divide and conquer, yeah?
BSTs.
Binary search tree, let's say searching a binary search tree is divide and conquer. Binary search is divide and conquer. So that just refers to problems you solve by splitting them into pieces and then solving the pieces and then recombining the solution to the pieces into an overall solution. So we'll sort of look at that. Then we'll spend some time on graphs. We'll talk first about graph decomposition, where we take a graph and extract information from it. That's depth first search. And then we'll talk about graph traversal, where we're looking for paths in a graph and such. That's breadth first search. So we'll look at topics related to graphs. What you'll find out is this is chapter 0, 2, 3, 4. Then we'll go back to chapter 1 of the book, which is, it talks about number theory algorithms and builds up to explaining how public key encryption works. It hasn't worked for me in the past to do it first, so I like to do it more toward the middle of the class. But it's a really fun topic it's easily within your grasp to understand how public key encryption works. Yeah.
In comparison to the older algorithms that we were doing in 2420, are we going to be reviewing those at all, or are we just going to be covering absolutely new algorithms?
Well, okay, so he's asking about algorithms in 2420, we'll be reviewing them. Yeah, along the way, when we're trying to understand algorithm analysis, as we do that, we'll look at things like insertion sort, selection sort, quick sort, and merge sort, and binary search trees, and such. Just sort of, illustrating maybe some new ideas with familiar algorithms that way. Okay, so then we'll start talking about greedy algorithms, which is just a class of, sort of a principle you can use to design new algorithms. We'll look at dynamic programming, which is another class of algorithms, another way to solve certain kinds of problems. We'll talk about linear programming. We will culminate by talking about the theory of NP completeness. And what we will find out is that there's a question that we'll study that's the most famous and important open question in theoretical computer science. And basically, there are lots of problems out there, optimization problems, say, problems where you're trying, I misspoke. Let me just say there are lots of problems out there that people would like to be able to solve. For example, UPS would like to know how to take a bunch of packages that have to be delivered and find the most efficient way to allocate packages to trucks and trucks to routes so that things are delivered in the cheapest fashion. Okay? Well, no one knows a good way to do that. There are ways to come close, and that's what UPS does, but no one knows how to find the absolute best way to do that. And what we'll see is there's good evidence that there is no efficient way to compute the ideal way to route UPS packages around. So looks like there will be butting up against a limitation, sort of a natural limitation on what computers can do efficiently. And we'll talk about that. And it turns out that, it looks like there are lots of problems out there that can't be solved efficiently, but people need to solve them anyway, do the best they can anyway. And so we'll see how to do that as our final thing. Okay, so I've talked about the highlights of the syllabus. There are more details in the syllabus, but I'm also happy to answer any more questions you might have about how the course works. Okay, I'll mention that the way consulting will work is we won't be hanging out in the CADE lab because for the most part you don't need to be doing heavy duty, well, you're doing caddis programming, but it's not strictly a programming class, and so we'll have our office hours in offices, I guess, is what I'm saying. So it'll be a little bit different, so you won't be using a TA call queue, for example. Yeah?
Now, with every programming assignment, are we allowed to kind of switch up our languages every so often?
Sure, yeah, with caddis, you know, like I mentioned, there's a page where you submit your problem, and you tell it what language you're using, and then you just...
The reason I was asking is because with dynamic programming, it's kind of hard to get up with C or C++.
Well, it depends what you have in mind as dynamic programming.
I have.
Yeah, so people look at dynamic programming and they think that means programming with dynamic memory or something, but it actually means something very different. Yeah?
I know it's probably not possible, but is it possible to test your algorithm in multiple languages, like submit it, get your grade back, and then submit it in another language to see if you can get it right in multiple languages?
Yeah, you can. What I do is, once a problem set becomes due, we're talking about the caddis problem, can you play around in multiple languages? I just look for the most correct solution that you submitted before the deadline, and that determines your grade. Yeah?
So the caddis problem is kind of an autograder, I'm assuming, right?
Yeah, so when he asked about the caddis autograder. Yeah, so when you submit a caddis problem, it's run against a hidden set of test cases.
And so you'll know that if you pass all those test cases.
You know if you pass them all.
Is that what the grade's going to be based off?
The grade is based on how many test cases you pass. But there's a catch. It's not based, the grade isn't linearly proportional to the number of tests you pass. If you pass all the test cases, you get full marks. If you pass all but one, that last test is worth a lot more than the previous test. I want to encourage you to really get all the bugs out and push through till you're done. And so I make it really worth your while to pass that last test. Yeah?
So when you say that the test cases are hidden, do you mean that the code is hidden, or just like the specifications in general?
No, the specifications aren't hidden. So I've got a, let's see. I brought this, I went to this page. This is a very simple caddis problem, but at least it'll show you what's involved. So a typical caddis problem, it begins with this description up here. It says the number S is called the mean of two numbers if S is equal to R1 plus R2 divided by 2. Mirko's birthday present for Slavko was 2 integers. Slavko calculated their mean, which also happened to be an integer, but then lost R to help Slavko restore R2. So essentially you're given R1 and S, and you got to figure out what R2 was. So, this is a one-line program. So typically there'll be a description like that. Then it'll tell you about the input, and it says there's one line of input, and there are these two integers, R1 and S. And then it says you're supposed to output R2 on a single line. So it's specifying the input format and the output format. It gives you some samples, and these are actually the first two test cases. So it does give you two free test cases in this case. So it says 11 and 15 were the inputs, and the output was 19. So when your program sees that, your program does that. When your program sees this, your program outputs that. And then there are other test cases that you don't see there. So when you want to submit it, you come up here to submit, and I'll have it logged in, but I don't remember my password, so I won't show you. But anyway, you submit it, and it tells you what happened. Yeah. One of you.
So out of all of the cases that are shown, will you know which ones have failed and which ones succeeded?
You know, if I remember this correctly, you know how many test cases you have. So you'll find out you failed the 10th test case or whatever. So you can tell if you're making progress or regressing.
Will there be any way of like outputting the output?
No, you can't. You can't instrument your program and produce output and debug it through Caddis. This is the mistake people make. Is they write their program and the only thing they do is they keep changing it and submitting it, changing it and submitting it, changing it and submitting it, and see if they can pass the test cases. What do you need to do instead? You need to test it yourself. You need to make your own test cases so you can debug it. Right? But writing a program and making sure it passes the first 2 sample test cases, that's good. But that's not enough. Sometimes, if you're really good, then you might get it right. But otherwise, you need to set up something that you can effectively debug. Yeah?
Now, for submitting code to Caddis, is there a text box entry or do you submit files?
Either way. You either drag and drop a file or you paste the program. That part's very straightforward. Yeah?
As for commenting code, like that shouldn't have any effect on Caddis, right?
No, Caddis, yeah, that, you can comment code or not as you see fit. Okay? Now, I'll tell you another thing people do is they struggle with the input and the output. Okay? So you're reading the input from standard input, right? So in Java, you're reading from system.in. In C#, in C++, you're reading from cin. And writing C out, or writing it to system.out in Java. Or they mess up the output. People put a common thing is people put debugging output into their program to debug and don't take it out when they submit. Well, if your program is outputting debugging stuff, it's going to fail the test case because it's not expecting to see your output, debugging output. Yeah?
Does Caddis have a way of creating your own test cases?
Well, he said, does Caddis have a way of creating your own test cases? Well, no. You create your own test cases by, in your programming environment where you're writing the program. Okay, any other questions? Okay, we'll take a break for a couple of minutes, then we'll talk about something different. Okay, so there seems to be enough concern about caddis there. I don't want to stress you out about it. Let me just show you something here. So what I did while you were taking your break is like this program here to try to solve that problem we just solved. So you can see what I'm doing is I'm creating a scanner in regional system.in, and I read in the 2 ints on the first line. I don't have to check formatting. I can trust that it's formatted like it says it will be. So I just read the 2 ints, S1 and R. And we're supposed to find an S2 such that S1 plus S2 divided by 2 is R. And we can do that by multiplying R by 2 and subtracting S1, if I remember all this right. So we just need to output 2 times R minus S1. Okay? So that's the whole program. Read from system in, standard in, write to standard out. So I can test it. So one way to, let's go back and find the problem. So when I'm doing these things, I will just copy the sample input. So that wants 19 is the answer, remember that. I'll come back here to Eclipse, and I'll run the program. And I'm not running the right thing. What?
String array.
What's that?
String array.
Not string, string array. In the main.
Yeah, you
method.
step-
Parameters, 2 brackets, R.
You're just missing.
The arguments.
Line 7.
Line 7, thank
Line
you.
7.
Public static.
After the string. Right.
Got it, thank you. Okay, so I just paste in the input, and that works even if the input's yay long. You just copy it all, paste it in, hit enter, and the program runs. Okay? So it's, this is why it's seductive to just test using the test cases I give you, because you just copy and paste them in. Well, you can write your own and copy and paste them in too. All right? Then I just copy the code. I come here to Caddis. I go to submit. Okay, it's Java. I have to tell it the main class, which is something like, I think I called it CS. I don't know what I called it. CS 1410. Well, wrong class, but CS 1410.s2. And it's changed. Oh, switch to editor. Right, and I paste it. And then I submit. And I have a compiler. Well, huh. Okay, that happens. What did I do?
I think the main file.
It's just this 2. Just this 2.
You think?
It looked like it was
Well, I thought it was easy. CS 1410.s2 is the main class. Oh, I give up.
You can't give up, this is due tomorrow.
You're gonna have to
Maybe
remove
don't have
line
it in a
1.
package.
Yeah, you have to remove line 1.
No, it's in. All right, here, I'm gonna do
So when you
this.
submit it to Caddis, just take out the package line.
Yeah, maybe. I'll copy that up to there. Sorry about this. That's what happens when I do something I wasn't planning on doing. See, it's easy. I guess you don't want to use packages when you're using Jumble.
Submit a zip file, I guess.
Okay. Okay, and you know, if you didn't get all check marks there, you know how far you got. That's how you know. You can run out of memory, it'll tell you run out of, you get a runtime error, it tells you. Yeah.
So it seems like the program is like you're not gonna have to submit multiple files. It's just gonna be like one.
Yeah, typically the programs will fit into one file. So just do the one file. Okay, I'm glad I passed the test. So. Okay, so maybe there's some CS 1410 skeptics. And so I've written down some objections that you might have for a class like this. That, it's a waste of time because one algorithm is as good as the next one. Or maybe you think, there's no need to study algorithms, I can just Google one up whenever I need one. Or maybe you think, this is all ivory tower stuff, I just use the libraries in my favorite programming language and everything works out just fine. Or you might say, what's with the lame pseudocode? Because typically I don't write real programs, I write pseudocode, give me an implementation in a real language. So those are possible objections and complaints. And you can, I'll let you, we'll think about that as we look at some stuff I got to show you here. So this is the Jumble puzzle. There's one in the newspaper every day. But you don't get newspapers, do you? But it's online too. And the idea behind the Jumble is you've got 4 anagrams in this case. And so you've got to unscramble the anagram. So what's that first one going to unscramble? Shove. And then going.
Kinetic.
Ticket, and then Avenue. Okay. And then you take the circled letters that would be there and you unscramble them. That's another anagram, and you get. It says the guy's saying, "Wow, traffic is really bad for a Monday. I'm out of tissues." The driver says, "The driver with the bad cold wasn't happy with all the." And you unscramble it. And sometimes you don't even have to. Congestion. It's usually a bad pun. Okay. All right. So I've looked at these things over the years, and I started wondering. On weekdays you have a couple of 5-letter anagrams and 6-letter anagrams. On Sundays it's like all 6 letters. And the question I had was, how many words are there that'll work? Where do they get their anagrams from? So what property would a word have to be able to use it in one of these slots?
It can't be an anagram for another word.
Right. It can't be the anagram for 2 words. Because we have to unscramble this to be shove. If hose were an English word, we'd have a problem. Because we wouldn't know, do we unscramble it to shove or to hose? And it would matter. So they have to find words that are unique in the sense that their anagram, it's a word whose anagram is no other word. No other word is its anagram. And I started wondering how many such words are there in the English language? How many 5-letter words, how many 6-letter words? And then comes the question of, well, how would you make a list of them? So that's what I want to talk about here, just to get us warmed up. An algorithm that would take a word, or not take a word, take a list of words, take a dictionary, say a list of 5-letter words, and figure out which of them have the property that can be used in Jumble. How many of them are unique in the way I just described? So first, let me make sure we're clear on what I'm after. I'm after words like shove and ticket. But I don't want a word like steam. What's the problem with steam? Why couldn't we use steam in those meets or teams? They have to be unique. So we need an algorithm to do that. Okay, so here's the input. The input's a list of words. The output I want to be a set that contains every word from the list that is not the anagram of any other word in the list. So suppose we had all 5-letter English words. Steak better not be in the output because skate, stake, takes, teeks are all anagrams of state. So that disqualifies stake as well as all these words. On the other hand, shove is okay. As it turns out, there's no other word that is anagram. That is this anagram. So we want to go through the list, pick out the good words, put them in the set, and the result is the set. Okay? So I'm going to stop talking. I want you to take a couple minutes here. Talk to the people around you, and I want you to see if you can figure out an algorithm. Okay? Now what I'm going to do is I have like 6 algorithms I'm going to go through, and hopefully you'll think of one of the ones that I have. But this will get you involved in the problem and help you understand what I'm about to do. So have at it. Introduce yourself. Okay, so in the past when I've taught this class, I've asked for people to describe their algorithm, and what invariably happens is the first one that's described is the best one, and it kind of ruins my sequence. So I'm not going to ask. But let's look at the first one. I call it Jumble Zero. So we're going to have our dictionary, which is our array list containing all the words. Solutions is an empty set. Then for each word in the dictionary, we go to this for each loop and go through all the permutations of the word. So if there's 5 letters, you commute it all the ways you can. How many ways are there to commute 5 letters? 5 different letters. 5 factorial, which is 120. So this loop will run 120 times. So for each permutation of the word, you see it's in the dictionary, which is that list up there. And you add 1 to count, and then when the loop ends, if count is still 1, that's good, because you found only 1 permutation in the dictionary, which presumably was the original word you started with. You add it to the solution, when you're done, you return the solution. Okay, that's about as straightforward of an algorithm as I can think of. What do you think of it? Yeah?
I was going to say, what would you call the size of that? It would be like n to the...
You talking about the complexity of this?
Yeah.
Well, we'll worry about the complexity later. I just want to... Yeah.
It works, but it's slow.
He says it works, but it's slow. Who could tell me what's the source of the slowness?
Everything.
Yeah? Everything?
You're looping through the dictionary twice and through every possible permutation of every word in the dictionary.
So we loop through the dictionary once in the outer loop. This inner loop runs 120 times. And each of those 120 times, we go through the dictionary. So we've got an outer loop that runs n times. This inner loop, the very inner, this search, basically, takes n steps. Because basically, if the words are k letters long, it's k factorial n squared. right? If you got rid of the distinct permutations and just did the lookup of the original word, it'd be n squared. Because so for every word, you're looking for it in a list. So each one of those lookups takes time in, you do it n times, that's your n squared. But we're actually doing 120 times more than that for 5-letter words, or 720 times that for 6-letter words. Got that k factorial, yeah.
Just for understanding, I thought the solution was to know if a random word grabbed was the solution, not to find a full solution to all. Of
You can pose it in different ways, but here I'm given a list, and I want to imagine. I think the designers of Jumble had to do something like this to start with. They had to figure out what all the anagrams they could use were, and so they probably have a list somewhere. This generates the list. Yeah.
Is the algorithm improved at all if instead of going through each permutation, we convert each word into a set of letters? And
Okay.
switch through it that way?
So what you're after is where we're going to end up is some way of eliminating the permutation generation. But before we go there, before we worry about but actually that's the most important thing, because if k gets big, if you're talking about, we'll talk about how bad it is later. Let's deal with the n part. How can we make, if we're willing to live with the permutations, how could you speed this thing up really cheaply with really not changing the algorithm? Yeah.
Would you use like a binary search tree?
Right. So instead of using a set, which is, instead of a list being a list, that we have to do a linear lookup on for each permutation, let's make it more efficient. Let's make it a binary search tree. Or a sorted list, or something that we can look up more efficiently. So this would be Jumble 1. We make our dictionary be a balanced binary search tree of words. Now, where does it pay off? Where does this help our program become more efficient? This right here. So now we're doing lots of these lookups. And instead of them taking linear time, now they take a logarithmic time. So we've gone from n squared k factorial to n log n k factorial. Okay. But the key thing is just to notice the inner loop is doing tons of these lookup operations. Make it more efficient. Use a binary search tree. So that's a very easy change. Not going to change the code much at all. What's something else we could do to make this faster? Yeah.
You could have a flag for like when you find something that already matches, then you
Okay.
can check that word again.
Okay. Well, I'm not sure if
Like if you had steak matches skate, then you wouldn't check steak because you already checked skate and you knew they matched.
I'm not sure how that flag would work.
That would hopefully reduce the amount of searches you're making. So let's pretend that you find that steak does match with skate, you would remove skate and
Oh, I see what you're saying. So we could just take, as soon as we find that steak and skate are, we could just go remove from the dictionary.
Yeah, and then you just don't want
Yeah,
to check
I
those.
didn't think of that. I don't think it's on my list, but that's a good idea. Yeah?
You can have a check where like count is like equal to 2
Okay.
and just break that.
You could also bail out of the loop early. That's what he's saying. So as soon as count gets to 2, there's no need to keep thrashing around. You just bail out on that word and try differently. That won't help us in the worst case, but it'll help us sometimes. What's another way we can speed things up? Yeah.
You could, assuming that these are English words are of different length, you can just earlier on before the distinct permutations for each word, you could just split it up into multiple.
Okay. So he's saying there's no point in comparing a 5-letter words to 6-letter words. You're never going to permute and do the same. But I guess I was implicitly assuming the dictionary was all 5-letter words or all 6-letter words to start with. But yeah, that's a good point. Yeah?
We can use a hash set instead of.
Okay, so another idea was we could use a hash table, a hash set, instead of a balanced binary search tree. It doesn't take any more code. You're just using a different library class, but that's slightly faster. So in fact, that's my Jumble 2. We just use a hash table. Okay? Okay, and then there's Jumble 3. Was another idea that was discussed, where when count gets greater than 1, we just break the loop. No need to continue looking. And then I could have added in the idea that you had which is when you find a word that causes the count to go to 2, you remove it from the list. So you don't look at it because you already know it doesn't work. Yeah?
If you remove from the list, don't you break the for loop because you don't have a length dictionary?
Well, yeah, that is a practical problem. This is, in a lot of languages, you're iterating over the dictionary, you delete the word in the dictionary, you break it. So it would make the code a little trickier. We could do it. But, yeah.
So here's I don't know about the complexity of this, but if you sorted each word into alphabetical order with the letters that were in it, then you use like the hash table or something, you could really quickly compare them, but that alphabetizing would probably take a long time.
So in fact, that's where we're headed. I'll explain more as we go. But the bottom line is, okay, we've improved it some. We improved it quite a bit, but it's still, this factorial term is going to kill us, especially if, let's say we weren't talking about words, we're talking about just strings of digits. And the strings didn't have to be 5 or 6, but they could be 100 long. You don't want to have a program that takes 100 factorial permutations of anything. That's just unimaginably large. Yeah?
Just a quick question, the if count greater than 1 part, that doesn't affect the worst case, does it?
Right. The worst case is going to be everything in the list is a good word. And so you never hit this. Yeah. So this doesn't help the worst case, but in practice it will help some. Okay, so I'm going to sneak up on my final. Jumble 5 is my final solution, but I'm going to sneak up on it. But I'm going to do it with this one here. So it's still structured the same way. We've got a list of words in our dictionary. We've got 2 sets, solutions and rejected. And so what we do is, we look at the word. If one of the words permutations in solutions, we remove it from solutions if it's in there, and we add it to rejected. Else, if none of the words permutations are in rejected, then we add the word to solutions. Now, let's look at it this way. Okay, so this is what we start with: a list of words and solution and rejected. So we check to see. So what do we check first? If one of the words permutations in solutions, we remove from solutions, add it to rejected. Well, is one of T's permutations in solution?
Yes.
No, nothing in solution. And then it says, else if none of the words permutations are in rejected, add word to solutions. Okay, so it's not in solution, it's not in rejected, so it goes into solution. What about tip? None of its permutations are in solution, none are in rejected. We add it to solution. Okay? Rat. Same thing. Now what about eat? Okay, one of eat's permutations is in solution. So what we do is, we remove it from solution, add it to rejected. Okay?